Good morning. Hope everyone's well. I also hope everyone's looking for a great July 4th weekend. Remember to stay hydrated. It's going to be warm out there. So today we're going to talk about torque basics. And before we jump into torque basics, I think it would be important to talk about where the torque wrench actually came from. A gentleman named Conrad Baer, a New York City plumber in the late 1800s, developed the torque wrench. He was an underground plumber and decided he got tired of crushing things. So he came up with this little invention called the torque wrench. Now, this is a clicker type torque wrench, and there are several different kinds, but this is the one we're going to be talking about today. The ones that you might see most are the clicker type, the dial indicating torque wrench, and a digital torque wrench. The digital torque wrench has come into its own here lately, and it's very popular among mechanics. But most people, like myself, have just the regular torque wrenches. This is an inch-pound torque wrench, and we'll talk about what all that is as we're coming up. Inch-pound, the one you just saw is inch-pound, and then we get into bigger things like a foot-pound torque wrench. Yeah, we can apply more torque with this one. And torque basics. So today, the objective is to teach you what inch-pounds in torque is and foot-pounds. So we're going to talk about the conversion of those two things. And we're also going to talk about correction factors, where what if I needed to add something to the end of my torque wrench to extend its length away from the torquing end of the wrench. I'm not talking about the handle side, I'm talking about the actual working end of the torque wrench. If I need to add something to this end, I'm going to have to adjust something on this end. And that something is my torque tool set point. My torque tool set point is whatever my torque wrench is set to. Now, let's say I'm reading the direction, it says set to 90 inch-pounds. Well, I adjust my torque wrench to 90 inch-pounds. That is now my torque tool set point. What if I made a mistake and set it to 85 inch-pounds? That's my torque tool set point. So don't get that confused. Whatever the wrench is set to, that is my torque tool set point. So, without further ado, let's jump into this thing. If I can just get my clicker to work. There we go. So first thing we need to kind of get some definitions down here. And the first one is torque itself. Torque is the measure of a rotational force. We just talked about our torque tool set point. Midpoint. The midpoint is the point between A and B. Let's say you have a torque of 50 to 100 inch-pounds, and the center of that is 75. That's your midpoint. That's easy enough. And it's best that when you're torquing to, if you have a range of any kind, like you'll see a range on mostly anything that you work on, go to the middle of that range, because most of your torque wrenches are not perfect. They may have a 3 or 5% error to them. So always go to the center of that torque range, and that way you're pretty well bet to have the proper torque. We talked about the adapter. It goes on the end, the working end of the torque wrench, as opposed to an extension that you see below there. Now, the adapter requires a correction factor. When the extension is put on the end of a torque wrench, do not put one on these kind because it could damage the clicker type end, but the extension does not need a correction factor if used as an extension alone. However, if you use the extension and you add an adapter, now you have to do a correction factor. And we're not going to jump into it that deeply, but we will talk about these things. So the first thing I want to talk about is the torque triangle. The torque triangle is a way I remember what the torque formula is. And the formula of torque is force times distance. As you see over to the screen here, right above the nominal center of the handle is a force. We're not worried about numbers right now. Let's just know it as a force. And then we have a distance, okay? We're not worried about the number of length of the wrench at this moment. It's a distance, so force times distance. What I can do and how I remember this is I cover up the T and I'm left with force times distance. Now the other end of that is I can cover up the F. When I cover up the F, I have torque divided by distance. Now I know my force. And same thing, I can cover up the D. Now I'm left with torque divided by force, and I'm left with distance. So whichever one of the torque triangle, the T, F, or D that you are covering up, that's the one you're looking for. Now what we're going to do is we're going to add numbers to the equation that we just looked at. We have 5 pounds of force being applied to a 12-inch distance. 5 times 12 is 60. Not that difficult, but we're working in inches and we're working in pounds. So that 60 becomes 60 inch-pounds. However, what if we used a foot? 12 inches in a foot, but what if we just used a foot? It becomes 5 foot-pounds instead of 60 inch-pounds. So how do I convert that 5 foot-pounds to inch-pounds? Well, I multiply. There's 12 inches in a foot. 5 times 12 is 60. And if I want to go from inch-pounds to foot-pounds, I'm going to divide by 12. It is that simple. In this case, I have 60 divided by 12, 60 inch-pounds divided by 12 inches per foot. Notice when I line through my inches, I have the FT for foot left. I'm left with foot-pounds. That's how it's done. It is not any. So, extra credit and extra points if you can tell me what kind of airplane these guys are working on. Give up? That is a C5. Earlier we discussed adding an adapter to the torque wrench. Keep in mind when I talk about an adapter, I'm talking about adding an adapter, much like you see on the screen here, to the working end of the torque wrench, not the handle side. I want to discuss this for a few minutes and just talk about what this correction factor is all about. If I keep my torque wrench at the same torque tool set point and add this adapter way out here, where I'm adding the torque is out here. So if I don't change anything on the handle side on my torque tool set point, I am going to over torque. I'm going to damage something, crush something. I could cause some problems. So I have to make a correction factor. In this case, here's what we do. We have the length of the wrench plus the length of the adapter. We add those two things together. We put them in the denominator, and then we put the length of the wrench in the numerator. So how do I remember this? LW plus LA, always in the denominator, length of the wrench in the numerator. So here we go. Length of the wrench, everything in the bottom. Length of the wrench on top, everything in the bottom. Now let's put a practical application. In this example, we have 100 pounds being applied to the nominal center of the torque wrench handle. The torque wrench itself is 12 inches long, but we're going to add a 4-inch adapter. So here's how we solve this problem. We have 12 inches over 12 inches plus 4 inches, which is 12 inches divided by 16. That gives us 0.75 or 3/4. I'm going to take that 0.75, which is my correction factor, 0.75 is my correction factor, times the 100 pounds. Remember, the 100 pounds was my initial torque tool set point. That gives us 75 inch-pounds. So what I do now is I take the 100 inch-pounds I have set on my torque wrench and adjust it to 75 inch-pounds. That is my new torque tool set point. Now I can go out to the airplane, go out to my car, whatever it is I'm working on, and torque with confidence that I'm not going to damage the product. In conclusion, I hope you learned something new about torque. You should know how to convert inch-pounds to foot-pounds, foot-pounds to inch-pounds, and if you happen to have to use an adapter, you now know you have to have a correction factor. So, what have you learned? Thank you for being here today, and thank you so much for this opportunity.